So this is going to be the introductory to the biomedical engineering unit. So what we're going to talk about is the different types of biomedical engineering. This is also known as bioengineering, which is kind of the grandfather of all of them. So there's bioengineering and then there's biomedical, which is specifically looking at the medical. This is a relatively newer field of engineering, and biomedical engineers integrate physical, chemical, mathematical, and computational science and engineering principles to study on biological, medical, and behavioral and health. So this is all about working with the biological things and engineering them for it. So there are subspecialties within it. So there is bioinstrumentation. These are going to be devices to diagnose, treat other diseases. For example, this could be electric sensors, LASIK, eye surgery, respirators, and ultrasound equipment. Looking at it, so this is a person's gait, so they're looking at how they walk. Then you have biomechanical. So these are going to be studying the motion and the fluid flow of chemicals or the body parts in order to develop devices that work with that system. So these can include artificial hearts, artificial heart valves, that's actually right here, artificial joints, and how, or even going so far as artificial, like an entire organ replacements, and how those work. Then there's biomaterials. So this is kind of going into the material science, but the biomaterial science, where they're going to look at development of natural living tissues and artificial materials, the use of the human body, or other organic parts. So this could be like making, designing and implementing new materials such as new tissues, such as you can create an artificial skin or artificial organs, artificial materials like ceramics and titanium for bone replacement that can actually work in the body. So you can actually build something that's biological in nature. Then there's clinical engineers. These are applications to technology to healthcare and hospitals, working with physicians to customize equipment to that can help the need of the hospital and medical procedures. This can be like hospital beds, dental chairs. How about mobile patient monitoring systems, like these things where you're attached to all the different things? Those are all done by engineers, but usually you don't think, oh yeah, an engineer built those. That was done by them. Then there is medical imaging, which is a big one. This is like building x-rays, CAT scans, MRIs, ultrasound machines, and that can look at specific phenomena using physical phenomena like sound, radiation, or magnetism, and high-speed electronic data processing can actually generate images using them. Then there's rehabilitation engineers. These are going to be engineers that are going to be working at rehab facilities that focuses on creating independence and capabilities to help individuals with physical or cognitive impairments, and may be able to help them in their mobility, communication, hearing, vision, cognition. So this could be like somebody who creates a typewriter for the visually blind. Or how do if somebody has some foot issues, they can actually cause some help with pushing on this is a foot controlled computer pad for a person who has no arms. So this is called system physiology. So engineering tools that use to understand the system and function within a living organism, ranging from the bacteria to the human. This involves experiments in computer modeling of data to make mathematical descriptions of events like metabolism or limb movements or skin healing. This is going to be down to looking at like how does it work on a mechanical process, on a molecular process, looking from bottom up and kind of seeing how things work, or top down looking at something like this. How does it all work together? So this is just kind of some of those special subspecialties within the biomedical unit.